Welcome back to another video. Gonna continue on with the same example. This time we're gonna do the other two, B and C. So I don't want to waste too much of your time, so let's actually just get started. So the next example, we have a 2 by 2 matrix. So it's the same one as the last one. So we're just gonna do the usual as every other step. Find the characteristic equation using the form of the determinant A minus lambda I. So that will be giving us 1 minus lambda, then 0, 0. Actually, let's split those up. Then we'll have negative 1 minus lambda. That is equal to 0, which is also equal to 1 minus lambda times negative 1 minus lambda. And so this gives us our eigenvalues to be 1 and negative 1. And so just like everything else, we just put in our eigenvalues into the matrix, and then we find our corresponding eigenvector. So we're going to start with the lambda is equal to negative 1. And this will give us 2, 0, 0, 0. So when we put this in row reduced echelon form, this will just give us 1, 0, 0, 0. So that means our solution will be x1, x2. It's going to equal to 1, 0 plus t times 0, 1. And so our eigenvector will just be what's in the nullity, which is our kernel. In this case, it will be 0, 1. So now we're going to do the same thing for the other eigenvalue. So when we put in the eigenvalue equal to 1, we will get 0, 0, 0, negative 2. Row reduced echelon form, get 0, 1. Well, not 1. Technically, we can put it like this. And so our solution will give us a nullity, or dimension of the nullity equal to 1. So this would be 0, 1 plus t 1, 0. And so our second eigenvector will just be 1, 0. And this leads us with the answer of lambda equal to negative 1 with v1 equaling to 0, 1 and lambda equaling to 1 with its eigenvector being 1, 0. Cool. So now let's move on to the next one. Alright, so this one is a bit more interesting. We got a 3 by 3 matrix this time. And so the good thing about this matrix is that it's a triangular matrix. And so if you recall from lecture, our eigenvalues is everything that's in the diagonal. So that means we pretty much already found our eigenvalues without finding the characteristic equation. We just look at the diagonals and we get that lambda is equal to 2, negative 1, and 3. And so now we can just go straight into just plugging them into the matrix. And so for the lambda is equal to negative 1 case, we get 3, 0, 0, 3. Is that 0? I think this one's 0. 0, 0, then 1, 2, 4. Remember, this has to be equal to the 0 vector. And so when you put this in row reduced echelon form, you will be getting 1, 1, 0, 0, 0, 1, then 0, 0, 0. So we can see we have the dimension of the kernel is equal to 1, which is good. It's expected. And so we'll have our solution x1, x2 is going to be equal to 1, 0, 1 plus, not, yeah, plus t times negative 1, 1, 0. And so this part will be our eigenvector. And so this will be v1. So now we can move on to lambda is equal to 2. So this would be 0, 0, 0, 3, 1, negative 2, negative 3, 2, then 0, then 3 minus 2 is 1. Putting this in row reduced echelon form, we get 0, 0, 0, 1, 0, 0, 0, 1, 0. And so we can see that our solution for this will just be 0, 1, 1 plus t 1, 0, 0. And yeah, this will be our second eigenvector. And now we have to do the last one. Lambda is equal to 3. And so we will get 2, negative 1, 0, 3, negative 4, 0, and 1, 2, 0. Row reduced echelon form. You can already see that this has a nullity dimension of 1 because we have 0 at the bottom row. When we put this in row reduced echelon form, we get not 1, not 0, 0, bleh, 1, 0, 0, 0, 1, 0, 5, negative 5 halves, negative 1 half, then 0. And so our solution simply becomes a 1, 1, 0 plus t 5 halves, 1 half, 1. And so this becomes our third eigenvector. And if you recall that we can multiply this. So we're just going to multiply everything by 2 so we can get rid of the halves. So this would just be 5, 1, 2. And so our answer will be lambda equal to negative 1 with its eigenvector being was it, oh, negative 1, negative 1, 1, 0, and then for the second one it would just be 1, 0, 0, and for the last one it will be 5, 1, 2. Yeah, that's pretty much how you find them. There's another way to solve them, or like to find the eigenvector, and that's pretty much guessing and checking. When I mean guess and check, you just kind of like, you look at the matrix and you just kind of have to eyeball what it is. And so I might do one example with that one, but it's mostly for people who can like quickly do it in their heads without physically writing this work, because this is kind of like a lot of work, and then some of it just kind of gets thrown away. For example, the solution and the half of like the equation, or yeah, half of the solution just gets thrown away. We're just only looking for the kernel, so it's kind of beneficial. We just solely want to look for the kernel. But other than that, that's pretty much it, and I will see you in the next video. I'm not sure if it's gonna be an example or a lecture. So yeah, bye.